Now that we have completed the quadratic equations, we are going to discuss linear equations. Before moving on to the methodology to be used to solve linear equations, we should first of all know as to what basically is a linear equation. So let us try and understand what is a linear equation. Linear equation is an equation of degree, how is it, 2. It should not be 2, it is basically 1. So linear equation is an equation of degree 1. Now, what do we mean by this equation of degree 1? Basically, you know that degree is basically the highest power in an equation. So in a linear equation, the highest power of any of the term would be 1, and it cannot be beyond 1. It cannot be 2, 3, 4 and so on. So this is how you define a linear equation. You remember that you would recall that in quadratic equation the highest power or the degree used to be 2. Likewise, in a linear equation the degree is 1 or the highest power is 1. So these are some examples of linear equation. The first one is in a linear equation in one variable, x plus 8 is equal to 17, and you can easily solve it. The second one is a linear equation in 2 variables, and the third one is a linear equation in 3 variables. So, and then there can be linear equations in more than 3 variables. They can be in 4, 5, 6 and so on. However, the power of any term cannot be beyond 1. It has to be 1. It cannot be more than 1. Now, how do we solve linear equations? As far as linear equation is with one variable is concerned, you simply have to do side change and then you would be able to solve the equation. So you simply have to do what? You simply have to do side change, which means here x will be equal to solve the linear equation means to find out the value of the unknown variable. There is one unknown variable here, x, so the value would be 17 minus 8. So this is going to be the solution of this linear equation, which has just one variable. For linear equation in 2 variables and linear equation in 3 variables, however, the methodology to be adopted is a little more complicated. If you have to solve linear equation in 2 variables, you have got 2 methods. One is the substitution method, the other one is the elimination method. Now you have to keep one thing in mind. If there is one variable that you have to find out, if there is just one unknown, then you need one equation. Even one equation is sufficient. On the other hand, if there are 2 variables, which is the case with this one, here there are 2 variables x and y. In these cases you will have to have 2 equations. Until you have 2 equations, unless you have 2 equations, you would not be able to find out the value of the 2 unknowns. As far as the equations in 3 variables are concerned, you again will have to have at least 3 equations to be able to find out the value of each of the variable, each of the unknown. So the basic rule is that the number of simultaneous equations that you are given should be at least equal, or it can be more than, it should be at least equal or more than the number of unknown variables that you are seeking to find the value of. So if there are 2 variables which are unknown, you need at least 2 equations. If there are 3 variables, you need at least 3 equations. In the first instance, linear equation in one variable, x plus 8 is equal to 17, there was just one variable, and that was why we were able to find out the value of that variable using that one equation only. Okay, now let us move on to the substitution method. We have taken up this example, 2x plus 3y is equal to 9, 3x plus 2y is equal to 11. So this is equation 1, 2x plus 3y is equal to 9, 3x plus 2y is equal to 11, equation 2. Now how do we find out how do we solve the linear equations using the substitution method? First thing that you will have to do is you have to find out the value of x from equation 1 in terms of y. So x in equation 1 has to be found in terms of y. So we need to understand how we are going to go about this. This equation is going to be taken up. So this equation is 2x plus 3y is equal to 9. So what do? We have to find the value of x in terms of y. So what do? We bring all other terms except the x term to one side of the equal sign. So we are basically doing this here. So we have shifted y to the right side, and now 2x is equal to 9 minus 3y. From here we can get this value, x is equal to 9 minus 3y whole divided by 2. Now this is how we have found out the value of x in terms of y. Now once you have done this, you will have to put this value of x, which is in terms of y, in equation 2. So this is the next step. So putting the value of x from equation 3 in equation 2. In equation 3 we have found out x is equal to 9 minus 3y by 2. Now please understand one more aspect. Here, to find the value of x in terms of y, you used equation 1. So when you have to find the value of x from equation 1, you have found out the value of x from equation 1. So now when you are putting this value, you don't put it in the same equation, you have to put it in the other equation. Since you have found out the value of x in terms of y from equation 1, don't put this value in equation 1, don't put it here. You have to put it in this particular equation. Is this okay? So you find out the value of one variable from a particular equation and then put that value in the other equation. Don't put it in the same equation. So putting the value of x from equation now in equation 2. So we cannot put it in equation 1 because equation 1 was actually used to find out the value of x. So we are putting it in equation 2. This is what we will get. 3x plus 2y is equal to 11. In place of x, we have mentioned 9 minus 3y divided by 2 whole divided by 2, which we had found as equation 3, and then we are adding it up. So you see that we have basically replaced x here by this value here, and then once we have replaced it, we will basically try and solve this. So 3 multiplied by 9 is 27, and 3 multiplied by minus 3y will be minus 9y. So this is how we have further simplified it, and now we'll have to take LCM. LCM would be 2. So when we take LCM, this is what is found: 27 minus 9y plus 4y. You can do this on your own. Please do it, keep doing it on your notebooks, and we simplify it further and then do the cross multiply. So 11 multiplied by 2 becomes 22, while what remains here is 27 minus 5y. And if you solve for this, you will get this value, y will be equal to 1. Again, once you have found this particular value, now you have to find the value of x. 1 you have solved, the value that you have got is 1. So you have to solve for x. The value would be, you know already that x is equal to, in terms of y, you know what x is. So x is equal to 9 minus 3y whole divided by 2. So what you have to do is basically, you have to put in the value of y in any of the equations that you have. You can put it in 1, 2 or 3. So what I have done is I have put it in 3. So since I knew that basically x is equal to 9 minus 3y, what you need to do now is you use the same expression now, and the same expression, equation number 3, we are using here. So x is equal to 9 minus 3y by 2. In place of y you put 1. So this is what you will get, x will be equal to 3. So you have basically got the solution, x is equal to 3 and y is equal to 1. But now you have to be very, very sure about this. And how can you be sure about your answer? You will have to cross check it. And how do you cross check it? You know the value of x and y, put it in the original two equations. So let me put it in equation number 2. If in equation number 2 I put x is equal to 3 and y is equal to 1, So I am trying to do that. Basically this is the equation that I am going to use. So in this equation, or let's say this equation, x if is equal to 3, 3x will be equal to 9, and if y is equal to 1, 2y will be equal to 2, and it adds up to 11, which is indeed equal to the value on the right hand side of the equal sign. So if I put these values, I get 11, and this is equal to this value here, which means my answer is correct, and the values that I have found for x and y, they are also correct. This is okay. Now let me do a slight variation of this question. Let us attempt a slight variant, wherein again we are going to use the substitution method, but this time we are also having a minus sign in the equation. 2x minus 3y is equal to 9, the first equation. So we have written it like this: 2x minus 3y is equal to 9 and 3x plus 2y is equal to 20. Again we'll be using the substitution method, and this time, last time what we did was we basically found out the value of x in terms of y, and then in the other equation we substituted x for the value that we have found out in terms of y, and that was why this was called the substitution method. Shall I go back? See here, if you look at equation 3, what we have done is we have found out the value of x in terms of y, and then in the next line what we have done, putting the value of x from equation 3 in equation 2, basically what we have done is we have replaced the value of x by 9 minus 3y by 2. So we have basically substituted x. So that is why this particular method is called the substitution method. The same thing we will do here, but this time let us substitute y. And to do that, the first thing that you'll have to do is you'll have to find out the value of y from one of these two equations. So we'll have to first find out the value of y from equation 1, and this value will be in terms of x. So 2x minus 3y is equal to 9. So I have to find out the value of y. So what I'll do is I'll shift the y to the right hand side. This minus 3y is shifted to the right hand side, and since it has been shifted to the right hand side from the left hand side, there is a side change. This sign, which is originally minus, would be plus. So this would become plus 3y, and 9 would be shifted to the left hand side, and the sign would now be minus 9, right? So now I have this expression: 2x minus 9 is equal to 3y, and then I can find out y is equal to 2x minus 9 whole divided by 3. This is the third equation. Now that I have found out the value of y in terms of x, what I'll do, I will be substituting y for this 2x minus 9 divided by 3. So I am basically substituting y for this value of y in terms of x. So I'll do this, but then I have to be very cautious, since to find out the value of y in terms of x I had used equation 1. I will be using equation 2 now and not the equation 1. So putting the value of y from equation 3 in equation 2, equation 2 is 3x plus 2y is equal to 20. So I do what? I put this value, I use this value to substitute y. So instead of y, now I have 3x plus 2. Instead of y, I get 2x minus 9 whole divided by 3. And this, since it has been given, is equal to 20. I'll do the calculation. 3x, I'll open up the bracket, so I'll multiply all the terms by 2, plus 4x minus 18 by 3 divided is equal to 20. I'll take an LCM. Taking the LCM, this is the expression that I'll get. Then I'll move on to this particular expression. I have cross multiplied 20 and 3. So basically this becomes 60. 13x minus 18 becomes 60. And x will be 60 plus 18 divided by 13, which is equal to 6. Now if I have to find out the value of y, what I'll do, I'll put this value of x in this particular expression. So I put this value here, since I know that y is equal to 2x minus 9 by 3, and when I put x equal to 6, it will become 2 into 6 minus 9 divided by 3. Is this making sense? Have a look here, and this way I'll get the answer as 1. So now my answer is x is equal to 6 and y is equal to 1. Is this fine? Now how do I check this? Again, I can put these values in the equations above. I can put these values on the left hand side, the expression on the left hand side of the equal, and then my result should be equal to what is the value given on the right hand side. So if I put x equal to 6 and y is equal to 1 in this particular equation, x is equal to 6 and y is equal to 1. So x equal to 6 and y is equal to 1. If I put 2x would become 12 and minus 3y would become minus 3. So 12 minus 3 is 9, which is equal to the right hand side term here, which means my answer was perfectly fine. It was correct. So this is how you also have to perform the verification once you have attempted the question. Thank you very much. In the next discussion that we'll have, we'll talk about the elimination method of solving the linear equations.